Okay, so this is to calculate the flat on the crest. Okay, so for a for a thread to mate properly with another thread, the 75% thread that we're calculating, it's important to make sure that the size of the flat is correct. Okay, because if this flat is not the correct width, we're talking about this dimension here, right? Because all of the threads that we manufacture have a small flat on the top of the thread. They're not sharp. And they're not sharp because, you know, a lot of the bolts, a lot of the fasteners we use are hardened. And you can imagine if this thread came to a sharp point, and there's hundreds and hundreds of these points on these threads, right? And then we heat treat or we harden these and we start engaging these threads. This, a certain point here on this thread is weak, right? I kind of tried to make this look like a crack, right? There's a certain point on that thread as it gets closer to the point that it becomes weak. When you harden something, it becomes more brittle. So you can imagine if we had to harden these fasteners and we tighten them into, say, a mold, right? We're putting two parts of a fixture or a mold components together, and we tighten up these fasteners. Can you imagine if 1, 2, or 20 of the points on these threads break off? You'll never disengage that bolt again, right? So just to save trouble, that's just one reason why. It's not the only reason. That's just one reason. So flats are intentionally manufactured on the top of threads. And really, we don't actually, in some cases, in a lot of cases, we don't actually create the flat. The flat is what's left behind when we finished our thread. So the deeper, if I get my single depth wrong, if I go too deep, the deeper I go, the more these two sides, right? The bigger triangle I get, and then eventually I lose my flat and it just becomes a point. So it's important to get my single depth right. So to calculate the flat on the crest, it's simply this. The flat is equal to the pitch divided by 8. Okay? So if it's a 1/4 20, it's a 0.05 pitch divided by 8. 0.05 divided by 8 equals 0.00625. We know to round to 3 decimals, 0.006. So the width of that flat is only 6/1000 of an inch. But keep in mind, you know how big a 1/4 20 bolt is, right? You can barely see the threads, let alone see a flat. So this is the calculated width of the flat on the top of the thread. So you could take that thread and you could put it in a shadow graph, right? Which magnifies your bolt. And you can, on those shadow graphs, those comparators, you can check the width of your flat.